So, welcome to the channel. Today we are going to discuss about a core architecture problem related to artificial intelligence that I think is very important but not discussed as much as it should have been discussed or it should be discussed. And that thing is quite simple. We often overlook this thing. And the problem is the context window of AI. So, in simple words, context window is the memory or the working memory of artificial intelligence or the large language models that we currently use in our chatbot or agentic system. So, in the beginning years of large language models or agent systems, or I should say RAG applications, we had simple workflows. You ask a question, you get an answer. You upload a document, you get an answer from that document. But as we scaled a bit, we realized that there is this problem with this workflow. The results are not as accurate or as deep as they should have been. So then we moved to agentic systems, which was quite magical at first glance, but it's not as magical as it seems. It's just an agent loop or an AI loop running in the background, running on a cloud VPS, iterating over a bunch of context, a bunch of injected data that has been retrieved from either some document or the web itself. But that's not a discussion. The problem that rises when we work with this agentic system is the context window, which gets flooded very quickly when we work with these systems, because these systems often have quite limited context window. Yeah, there are some exceptions like Gemini from Google Cloud, from Google Gemini or Claude Opus models, Claude Sonnet models, and some other models that have a big uh, context window of 1 million tokens, or some models like Qwen from China, built by Alibaba. They have the models with context window of 128k tokens, which is quite big. But there is this problem with huge context windows. As the context windows increases, like the number of tokens increases inside this uh, basic neural net or the context window of the large language model, it tends to hallucinate more. Well, it doesn't hallucinate like we do, but it's just a term that we have given to this phenomena, because large language models are tend to be hallucinative by design. That's why they are generative. Calculate the probability. They can never be generative and never be as creative as they are. So it's their nature. But this affects how we operate them, how we use them in our workflow. And that problem affects us in millions and billions. And this is not a thing that I'm saying. Many researches and many problems have already been uh, reported where these hallucinations have costed in millions. So this is a problem that should be addressed. But there is this argument that I would like to give, which is even if we somehow manage to increase the context window of these large language models to 20 million tokens or 100 million tokens, which is a big number, I think we are still going to face this problem, because there's going to be a lot of data for the large language models to process. And as the data inside the neural net or the working context window of the large language model increases, the cost of processing is going to increase as well, which increases quadratically. So for each next token, the time complexity increases quadratically, which means it's not linear, it's quadratic. which is very expensive in the long run. And we are already seeing the cost of API, the subscription based or token based systems already being implemented by big tech companies, because it's not sustainable in the long run, because these models are energy hungry, they require a lot of power. The companies are already signing SMR deals for small modular nuclear reactor deals. So it clearly shows how this technology is not sustainable. Having a large context window has its own drawbacks as well, but it's also a mandatory or required thing, because if a system doesn't have memory, how is it going to process something? I personally believe that this technology, we cannot improve it any further, because the godfather of AI and the pioneers of this technology themselves have said it already, that these generative models have reached a threshold of being good. No matter how much we scale it, no matter how much we train it, this technology is not going to improve anymore. And they're going to be slightly better benchmarks on paper, but in real world this technology has yet to prove its worth. But there's something that I think we can do at the orchestration layer of large language models, because what we see, like if you look at Claude, there are a bunch of things that it can do, but it's all it all around the large language model. The large language model itself is not able to do anything. It's not able to surf the web. It's not able to read a document. It needs tools. It needs an environment, a sandbox environment or a working environment to engage with these tools. So at orchestration layer, we can probably do a lot of things which can improve the outcome, the way these models act, the way these models work. So yeah, that's something I think we should do and we need to do. We should work on improving the orchestration layer. We currently use a quite heavy and big set of frameworks to orchestrate these models, inject memories, have them see their previous conversation. But I think we can do pretty better. This problem should be taken under consideration, because it affects how this technology lives with us in the long term.